Welcome everyone to the study guide review video for the 7th grade Unit 4 test. Now I always think the best way to use these videos is to try a question first, then watch the review video of me explaining it, and then check your answer, right? And then move on to the next question, or do the entire study guide and then go through one by one. So I'm going to try to set up today's video to more facilitate that. So if you haven't already done question 1 yourself right now, by yourself without help from anyone else, you should try question 1 right now. Okay, pause the video and then come back. And now I'm going to explain how to do it. Okay, so we have a pencil is 120 millimeters long. A marker is 9% longer than the pencil. How long is the marker? Show your work and select the multiple choice answer. Okay, so as will consistently be the case here, there's 2 different ways of solving this. The way that people seem to feel a little more comfortable with is we recognize that 9% is our percent increase. Okay, and I can write that as a decimal, 0.09, right? And now I have my original is 120 millimeters. And I'm trying to find how long the marker is, which we know is 9% longer. So we can see this is like the new amount. Okay, whenever we're trying to find the new amount, we can take the original times the percent change. So I'm going to multiply 0.09, again, 9% in decimal form, times 120, and we get 10.8. That means that the marker is going to be 10.8 millimeters longer than the pencil. Okay, so that's not my final answer. That's how much longer it gets. So what we need to do then is we add the original, which is 120, plus the amount of the change. And we would do that, we're going to get 130.8 millimeters. Okay, so the answer is going to be A. So in that strategy, we multiply by the 9% to find the amount of the change, and then we add the original to the amount of the change. Okay, the more direct way to do it is we know that if it's 9% longer than the original, okay, then it's like we have our 100% of the original plus our 9%, which is 109%. Okay, so we can get that. We're going to write that as a decimal, 1.09. And then we're going to multiply by the original, which is 120. And when we do that, we're going to get directly that our new amount is 130.8 or 0.8 millimeters. Okay, because 109% of something is the same as making it 9% increase or 9% longer in this case. Okay. All right, so now if you haven't already, you should pause the video and try question 2. And now I'm about to go over it. Question 2. The temperature in a room is 20 degrees Celsius. A thermometer measures it at 20.8 degrees Celsius. What's the percent error in this situation? Okay, so to find the percent error, what we're going to do always is we're going to find the amount of the error, which we can figure out by subtracting, and then divide by the correct or the desired amount. Okay, so in this case, and then we multiply by 100 to make it a percent. It's actually 20 degrees Celsius, but the thermometer measures it at 20.8 degrees. So we can subtract those to find the amount of the difference. And the amount of the difference is 0.8 or 0.8 degrees Celsius off. That's the amount of the error. And then we're going to divide it by the actual correct temperature in the room, which is 20 degrees Celsius. And then we multiply by 100. And we're going to get 4%. So this is a 4% error. Cool. All right, same thing. Do question 3 if you haven't already. Pause the video and come back to hear the explanation when you're ready. The population of Bristol, PA is about 53,110 people. 30 years ago, the population was about 56,500 people. By what percent did the population decrease between 30 years ago and now? So similar to the percent error formula, to find the percent decrease, okay, we're going to find the amount of the decrease, and we're going to divide that by the original amount. So in this case, and then we'll multiply by 100 to make it a percent. Okay, so again, to find the amount of the decrease, we're going to subtract. So I'm going to subtract 56,500 people minus 53,110 people. And that's going to be 3,390 people. So 3,390 less people live there. And then we're going to divide that by the original, so the earlier one. So the population of Bristol, PA is this. 30 years ago, it was this. So if that's 30 years ago, that's the original. That's the old one, right? So then we're going to divide by that 56,500. We're going to multiply by 100. And that is going to give us the percent that the population decreased by. And when you do that, you're going to get exactly a 6% decrease. Okay, so remember to find the amount of the error or the amount of the decrease. You're going to subtract the two values, and then we're going to divide by the original or the correct amount. Awesome. All right, now we have question 4. So if you haven't tried it already, go do that now. Nyla purchases a rug that costs $50. A 10% sales tax is applied. After the tax, Nyla uses a 10% off coupon. She will pay A, exactly $50, B, more than $50, C, less than $50. Explain your thinking. Okay, so the thing they're testing you on here is the fact that you don't undo a 10% increase by a 10% decrease. Okay, those don't undo each other. That doesn't get us back to 50 because we're taking the percent of the whole. So, I mean, I really think this is how I would do it. People can do it more conceptually, but I would probably just do out the math, right? And we'll see. So if I start with $50, that's my original amount that she purchases the rug for. And then I have a 10% sales tax is applied. That means it's getting 10% more expensive. So you could do this in 2 steps, but I'm kind of going to skip to this. So I'm going to do the $50 times 1.10 or like 1.10, right? Because it's like 110%. And then that's going to tell me that after the first tax, after the tax is applied, now I have to pay $55. But then 55 is now my new original. Okay, so if I have $55 and then I get 10% off of that, now instead of paying for 110% of that, I'm paying for 90% of that. So I'm going to multiply by 0.90. And when I do that, I'm going to get $49.50. So the answer in this case is less than $50. Now for the explanation, if you have the work, I would accept that. But the sort of conceptual idea is here we're taking 10% of $50, so that gets bigger. But then we're taking 90% of $55. So since we're taking 90% of a bigger number, then it means we're going to take away more, right? Because it's all about the percent of the whole. So that is the idea. And then what I did here, multiplying by the 1.10, right? I also could have just multiplied by 0.10 or like 0.10, right? 10% in decimal form. I'd get $5, and then I would add that to 50 to get $55. And the same thing here, I could have done 10% of 55, which would be $5.5 or $5.50, and then subtract it, right? So this is just sort of like the this version. Either way is fine. Okay, awesome. All right, question 5. Miniature candy bars are 70% smaller than the original. Select all of the equations that represent this, where y is the length of a miniature size candy bar and x is the length of the original size. Okay, so here we have my original candy bar is always going to be 100%, right? That's my starting, that's my initial. We think of the whole thing as 100%. And then my miniature candy bars, they're 70% smaller. So that means that my miniature is only 30% of the original size. So that means this is going to be one of my correct equations. If I have a 70% decrease, okay, that means I'm paying 30% of the thing. And then the other equivalent equation that we have here, right, is the other way we could do this is we could take the original amount, which is x, and then we're going to decrease it by 70% of x, or subtract that away. So we get there. If we had a 70% increase, this would be correct. This would represent a 30% decrease, and the multiplication is just wrong, and it's going to confuse you. Just there to confuse you. Okay. Oh, I didn't say it this time. If you hadn't done 5 already, you should have done that. And now if you haven't done 6 yet, pause the video and go do that. For 6, 3-part question. All of the questions we're talking about Nicholas, who has a coupon for a 60% discount at his favorite store. Is there a proportional relationship between the original price of an item and its price after the discount? If yes, what's the constant of proportionality? If no, explain. Okay, yes. When we're talking about percents are an example of a proportional relationship, right? We can just multiply one number by the percent and it gives us our new amount, right? So the amount after the discount is the original times that constant of proportionality. So here, if it's a 60% discount, that means we are not paying for 60% of the thing. Our original would be 100%. Okay, so that means we actually only pay for 40% of the cost of the original item. So my equation is that the discount price, y, is going to be equal to 40% of x, 0.40 times x, the original price. So as we can clearly see from this equation, the constant of proportionality is 40 hundredths, or 0.40. Okay, for 6.2, it is worth noting that you could also write, like it is another correct equation, is x minus 0.60 or 0.60 times x. That doesn't like show you the constant of proportionality, so it's less helpful for this question, but it is also a correct equation, and so you would get full credit for that. But either way, the constant of proportionality has to be 0.40. Okay, and then finally, we have that the price of a coat after the discount is $21. What was the original price? Okay, for this, I'll do boxes and then I'll erase and I'll do something else. It's up to you. Some of you seem to find it helpful. Some of you find the boxes confusing. But here we're looking for the original price. So when we're looking for the original price, that's when we're going to have to divide by our constant of proportionality. So after the discount, the new price is $21. And we know that if we have a 60% discount, right, then we're multiplying the original by 0.40, right, like we have in our equation, and that gives us the new amount. So if we know the new amount, we're going to have to divide by that constant of proportionality, and we will get that the original is $52.50. Okay, we should check to make sure that makes sense in the context. The new amount is less than the original. That makes sense because we have a 60% off coupon, right? So the original should be more expensive. Okay, you can do it that way, or we can use the equation more clearly. The equation, y, which is the discount price, is 0.40 times x. The discount price is $21. So we're trying to find the original price. Okay, we kind of have this equation. And then the same idea, x is being multiplied by 0.40. So we can divide 21 divided by it, and we'll get the same thing. So you can write it out either way. You don't technically need to write it out, but you do need to understand that you're dividing by that constant of proportionality to find the original price. Cool. Okay, if you haven't already done question 7, pause the video and do that now. Here for 7, we have the cost of new cars and trucks are expected to increase 2.9% each year. The DES car currently costs $17,000. What is the expected cost of the new DES car next year? Okay, so this one, 7.1, should be pretty straightforward. It's a 2.9% increase. That's my percent increase. So if I want to find the new cost of the car, right, I have the original cost of the car. When I have the original and I have the percent increase, I'm just going to multiply my original, $17,000, times the percent increase. 2.9% is going to be 0.029 in decimal form. And when I do that, it's going to tell me the amount of the increase. So this car has increased by $493. Okay, we got to be careful. That's not the answer. That's the amount more expensive the car gets after this first year. So then we add that amount of the increase to the original amount, and we get $17,493. Okay, or we could have just directly done 17,000 times 1.029, knowing that a 2.9% increase is the same as taking 102.9% of the original. So either way, you get that answer, you're good. Okay, 7.2, write an equation that will help you calculate the cost of other cars next year. Use X to represent this year's cost and Y to represent next year's cost. Okay, so 2 different equations that would work here. To find next year's car, Y, I'm going to take, the way I did it here is the current cost of the car and multiply it by our 2.9% in decimal form, 0.029. And then I multiply that by X, the original cost of the car. And then I add that to X, the original cost of the car. So that's an acceptable equation. Or it would be 1.029 times X, right? For the same reason, 100% plus 2.9% is 102.9%. And then for 7.3, still talking about the same thing, the cost of the new DES truck is currently $22,000. If the percent increase stays constant, what will the cost be in 2 years? Okay, so in 2 years, each year we have a 2.9% increase. So we're going to take our original cost of the car, $22,000. And I think it is faster here to use this strategy, right? Not the one I used before. Take that $22,000 and multiply directly by 1.029 because that's my 2.9% increase onto the original 100%, so 102.9%. Okay, or you could do it this way. You could multiply just by 0.029% and then add it to the original. That will completely work, sort of like one more step in the calculator. Okay, here you're going to get $22,638. That will be the cost after 1 year. So if you want to find the cost after 2 years, you take that amount of money, right? Because this is now like my new original. And I again multiply it by my 2.9% increase, or the 102.9% of the original. And when I do that, I'm going to get about $23,295 after 2 years. So that's going to be my final answer. Okay. So it doesn't matter really how you write it out, right? If you do, again, this method, but either way, it's the 2.9% increase. You have to be careful that however much money this increased by, so $638, you don't just add that again. You don't add 638 a second time. You have to recalculate because now we have a new whole. Now we have a new thing we're taking the percent increase of. All right, and last 1/2 questions, 8.1 and 8.2. If you haven't given those a try yet, pause the video and do it. Okay, and these actually come directly from last year's MCAST. The price of a hammer at a local hardware store is $15. The store is offering a 10% discount off the price of the hammer. There's a 7% sales tax applied after any discounts on all purchases. What will the final cost in dollars of the hammer, including the costs, the discounts, and the sales tax? All right, so it originally starts out at $15. And then the first thing that's happening is we have a 10% off discount. Okay, so we're going to figure that out first. Again, 2 approaches. You can multiply by 10%, and that's going to give you $1.50. And then you can take that $1.50 off and subtract $15 minus $1.50 is going to give you $13.50. So that's the cost after the discount. Okay, you could do that, or you could do 15 times 0.90, 90%, because a 10% off discount is the same thing as taking 90% of the thing. Either method works. Either way, you should get after the discount or at $13.50. Then we have a 7% sales tax applied after any discounts on all purchases. So now my original is $13.50. I want to find 7% of that. 7% is 0.07. Okay, I'm trying to find the new amount, so I'm multiplying. And this is going to be about $9. Or sorry, whoops, not $9. That is going to be about 95 cents. It would be 0.945, and the 5 would round the 4 up. So that's about 95 cents. That's, of course, not my final answer. That's just the amount of the increase. So then I can do the $13.50, add the 95 cents, and we'll get the total amount that we're paying is $14.45. And again, the other way we could have done this is we could have done 15 times 90%, and we would have directly gotten the $13.50. And then we could have done the $13.50 times 1.07, because we'd have a 7% increase, and you would directly get the $14.45. So either way is going to work. Okay. And finally, the same hammer is available from an online retailer if a customer uses a discount code that offers a 25% discount and free shipping on the hammer. Their hammer will cost $13.50. If there's no sales tax, if the customer buys the hammer online, what's the original price of the hammer from the online retailer. So we're finding the original price, right? So if we're trying to find the original price, this is a situation where we're going to ultimately have to divide, right? And sometimes the boxes, I think, can be helpful. Okay, so the original is what we don't know. We know that the new price is going to be that $13.50. And we know that that comes after a 25% discount. So we think the original is 100%, and then I'm discounting that by 25%. So I end up paying 75% of the original cost. So the original times 75%, or 0.75, is going to give me the new. So if I want to find the original, I work backwards, I do the opposite of that, and I'm going to take my $13.50 and divide by 0.75. And that is going to give me $18. So the original hammer was $18. And then when it is 25% off, it becomes $13.50. All right, that's it. The test is just like it. If you just did those problems along with me, that's huge. Even if you didn't get them right the first time, you didn't get them all right, that's really helpful. If you did get a lot of them wrong, I recommend that you do this process over again. So get a new copy of the study guide, or erase the copy you had, or look at one online. Pause the video, retry the questions, then watch me explain it, right? That's the way you learn.